All right, looking at some additional examples here. Here's an example called the double spin. And the double spin is a fair game. The player gets to spin a spinner twice, but wins only if the same number comes up both times. The $100 sector is 1/8. Make an area model or tree diagram to show the probabilities of every outcome of the two spins, and then answer the following questions. So I'm going to make an area model. If you prefer a tree diagram, go right ahead. But since we have two spins, we can use an area model, spin 1 and spin 2. So we have 4 different outcomes. We have the $100 outcome, which we were told is 1/8. So I'm going to write the value plus the probability. That means the probability of $1, this is half of it, 1/8 is here, so this would have to be 3/8. And then 10 and 5 are both 1/4. And since it's the same spinner twice, we'd have the same thing on this side. And notice how we are going all the way across for these because we are spinning 2 spinners no matter what. So the first problem says, what's the probability of winning $100? So the way we win the $100 is by finding this area, which is 1/8 times 1/8. 1/8 times 1/8 is 1/64. Again, we're always finding the area. It's 1/8 wide, 1/8 tall, so 1/64. What is the probability of what is the probability of winning anything at all? So I would win $100 in this space. I'd win $1 in this space, so 3/8 times 3/8 is 9/64. I'd win $10 in this space, so 1/4 times 1/4 is 1/16. And I'd win $5 in this space, which again is 1/4 times 1/4 or 1/16. So what I'm going to have to do is I could win in this space or this space or this space or this space. So the key word is or, so I'd be adding all those. So I'd be adding 1/64 plus 9/64 plus 1/16 plus 1/16. So probability of me winning, and again, you could either type this in your calculator or you can get the common denominator for all these, which would be 64. It would be 18/64, because these would be 4/64s, or 9/32. Remember, probability can be written as a fraction, decimal, or a percent. So I'm just leaving it as a fraction, a reduced fraction you want to leave it as. If you wanted to do 9 divided by 32 in your calculator, you get 0.281. You could 0.28125. You could put that in there, or you could say 28.125%. All acceptable answers. So what that means is, what's the probability of winning? So the probability of winning is this. Probability of losing would be all these other blocks. So what I could do is find all these areas and add them up. But since that's a lot of different areas, it's probably going to be easier to remember that probability is always out of 1. And if I know my probability of winning and I take that away from 1, then I get my probability of losing. So I can just, the easy way to do this is to say the probability of losing would be 1 minus this probability of winning, which would be 9/32. So if I do 1 minus 9 divided by 32, and make that a fraction, I get 23/32. Which I could also leave it as this decimal or move the decimal over twice to make it a percent. Then it's asking what is the expected value for this game. Okay, so I'm going to put my probabilities up here still, and my expected value is going to be here. So, expected value, you're taking your probability of each outcome times the value you get from that. So my probability of $100 is 1/64th, and I would win $100 from that. So I'm multiplying 1/64 times 100. I'm adding to that my probability of $1, which is 9/64ths, and I win $1 from that. I add to that my probability of $10, which is 1/16th times the value, which is $10. And I add to that my last win, which would be winning $5, which is 1/16th, and I would win $5 from that. So when I multiply those together and add them all up, I would get $2.64. So I would expect to win on average, every time I play this, $2.64. Now, playing this game, I can never win actually $2.64 because those are my only possible outcomes. But if I play this a long amount of time, that's what I would expect to win per play on average. And then part E says, if it costs $3 to play the game, should you expect to break even in the long run? So if I play this hundreds or thousands of times, and it's costing me $3 every time I play it, but I'm only averaging $2.64 winning back each time, then no, I'm not going to be winning money over a long period of time. If you only played it a short amount of time, yeah, maybe you get lucky and you win one of these bigger numbers early and then you can stop playing and then you win. But if you're going to play it hundreds or thousands of times, you're probably going to lose money because you're expected to only win back $2.64 and it costs you $3 to play. All right, another example. Is our pick a tile game. So our pick a tile game says Marty and Jerry just had lost playing double spin, and they ran into another game they had never heard of, pick a tile, in which a player has to reach into a bag and choose one square tile and one circle tile. The bag contains one yellow and two red squares, as well as one yellow and two red circles. To win the game, which is a large stuffed animal, a player must choose one blue square and one red circle. Since it costs $2 to play the game, Marty and Jerry decided to calculate the probability of winning before deciding whether to play or not. So here we're asked to draw a tree diagram first. So our tree diagram would be, first we're going to pick the squares. And there are three colors for the squares. We have yellow. We have blue. And we have red. And there are 3 yellow squares out of 6. So 3/6 or 1/2. Blue is 1 blue out of 6, so 1/6, and red is 2/6 or 1/3. Our circles are going to come next. And we have 2 possible outcomes for that. We have yellow and red. And there's 1 yellow out of the 3 total, and then 2 red, so 2/3 for red. I'm going to repeat that for each one. So that's our tree diagram. If we were to draw an area model for this one, again, we now have our squares along the top. draw our square. There's 3 colors, so it would be yellow, which again is 1/2, blue, which is 1/6, and then red, which is 1/3. On the other side, we'd have our circles, which is just going to be yellow of 2/3 and red of 1/3. So that's what our area. So we have both these models. We could do both because there's only 2 possible events for each one. And then it says find the probability of winning and the probability of losing. So if I'm find the probability of winning, again, remember you win if you pick a blue square and a red circle. So blue square, red circle is here. So that's 1/6 times 2/3, which is 2/18 or 1/9. So the probability of winning is 1/9. We could also come up here, and we could have done a blue square with a red circle, and then I'd be doing it in 1/6 times 2/3 or 1/9. Probability of losing then, again, the easiest way to do that is once we know our probability of winning is to take 1 minus our probability of winning, which would be 8/9. Or again, I could really find all these areas, add them up, which is going to add up to 8/9, but that's going to be a whole lot more work. So the easiest way to do this is doing 1 minus 1/9 and get 8/9. All right, and it says, would you play this game? Do you think it's fair? Well, you only have a 1/9 chance of winning, 8/9 chance of losing. So it's not really a fair game, but if you want to go to Carnival, most people want to play games of Carnival, so maybe you would play it, but chances are you're not going to win.